Alright, in this video we're going to look at what a least common multiple for monomials is, and to do that I'm going to compare it to a GCF, known as my greatest common factor. GCF, greatest common factor, this has its uses. We see it a lot in factoring, reducing fractions, alright, and that's where we primarily see it when we pull out that GCF. When we factor, we pull out a GCF first. We also pull out the GCF out of the rows and columns of our generic rectangle. And in reducing fractions, we pull out the greatest common factor in the numerator and denominator to help make things smaller, which reducing fractions means it would also come by when we say simplifying rational expressions. That's the uses of a greatest common factor, and that's where we've seen it before. So in a greatest common factor, we are looking for two things. We are looking for the largest number that goes into both of the numbers provided to us, and we're looking for all the variables that have in common. The one thing I really want you to catch on to, though, is that factors are fewer. All right, factors are fewer. Okay, they are less than the two numbers presented to you. So if I'm looking for the factors in my numbers first of 12 and 36, my factors of 12 start with 1 and end with 12. That's the range, minimum, maximum of my factors, 1 and 12, the lowest and highest factors. And if we continue that factor rainbow, you can see you get 2 and 6, and you get 3 and 4. Those are the factors of 12. 36 starts off again with 1 being our lowest factor. 1 is always the lowest factor, and 36 being the highest factor, our maximum. That's why a factor can't be more than 36 here. All right, and if we continue on, we get 2 and 18. We find we get 3 and 12. All right, you get 4 and 9, and then you get 6 times itself, 6. And those are all the factors of 36. Well, what's the greatest one that we have in common? Well, the greatest one in common is 12. All right, we deal with the greatest common factor and not the lowest common factor. Why don't we deal with the lowest common factor? Well, the lowest common factor is always 1. It's always going to be 1, and that's why we just don't do it. You can't dividing by 1 doesn't change anything. So our greatest common factor between these two is 12 in this case. All right. Now you look at the variables. Do they have any variables in common? No, they don't have any variables in common. In fact, remembering that it's fewer means you're going to take the fewest of either variables that are offered. Let's look at our x's. In the first one, I have 1x. In the second one, there's no x's. What's the fewest of x and no x? Well, no x's is the fewest, which is why I take no x's into my GCF. All right, what about my y's? Well, in my y's, I've got 1 y here and no y's here. Well, the fewest, again, is no y's, so I take no y's down into my GCF. All right, so 12 is my GCF. Let's take a look now at the least common multiple. Multiples, I want you to remember, are more, or they take the most out of things. All right, when we talk about our variables. Multiples of 12 are starting with 12. Then they go 24, 36, 48, and so on. Multiples are more than the number. All right, they're more. Look at 36. 36 starts off with 36. It starts with the number itself, and then it counts up from there. 72, 108, and so on. Multiples are more. All right, so why don't we ever find the greatest common multiple? Well, multiples go on forever. You would never be able to find the greatest common multiple because multiples are infinite. So we do find the least common multiple, and our first multiple we come across here is 36, making 36 the numeric piece of my LCM. But just like my GCF, I want to look for not only the number that's my least common multiple, but also the variable. And in the variables, I want to remember that multiples are more. Multiples take the most that either has to offer. 1x versus no x's, the most is an x. So I'm going to take that 1x there. All right, y's, 1y versus no y's, the most is 1y. So I'm going to take that y there. All right, so that's the basic general thing. We use least common multiples in a lot of things. We will use least common multiples when we are looking to get a common denominator for adding fractions. All right, when you're looking to get that common denominator there. We also look for it when we are looking to get rid of fractions, all right, in equations using a process called fraction busters. All right, so least common multiples have their purpose as well. So let's identify some examples here. Let's get the GCF of 24 and 40 first. GCF, largest number that goes in 24 and 40. Pause it. Try and get it on yourself. It is 8. Now go for our variables. What's the most that either has to offer? 1x, x cubed. Factors are fewer. All right, the fewest that either has to offer is x. All right, now look at my y's. Y cubed, 1y. The fewest is 1y. That's my GCF. Least common multiple. Multiples are more, or they take the most. All right, so more, we start with 40 and 24, and we go up from there. Now, one thing to help you, instead of just listing out all the numbers of 40 and seeing which one does 24 go into, you can use your calculator. Get your calculator out, and in your calculator, let me pause our video for a second. All right, take a look. Here's my calculator right here. If you go to your calculator and you press this math button, you will see in option 1 here, you will see LCM. All right? And you can pull that LCM. So that's what I want you to do. If you pull that LCM, the LCM only works for 2 numbers, but you can push 24, and then you need to put a comma. Your comma can be found right here. All right, right there on your calculator. All right, and you put a comma and you put 40, and then go ahead and press equals and see what you get. All right, and least common multiple in this case is 120. Now multiples are more. They take the most that either has to offer. Look at your x's. 1x, x cubed, the most is x cubed, and y cubed and y, the most is y cubed. That's my least common multiple there. Let's go to the next one. All right, between 16 and 24, largest number that goes into 16 and 24 is 8, so that's my numeric greatest common factor. And then look at my y's. Y squared, well, they're the same. So there's no fewer, there's no more, it's just y squared. Now go to my multiples. Again, get out your calculator. Plug in 16 and 24 into your LCM, and you should find that the least common multiple is 48. And the most that either has to offer is y squared, because they're the same. Let's go to our next one. All right. Greatest common factor of 30 and 40 is 10. And what is the fewest of our variables that either has to offer? A cubed is the same in either. And b versus no b's, I'm going to take no b's for my GCF because it's fewer. I take the fewest that either has to offer. Look at my least common multiple. Least common multiple between 30 and 40. Go ahead and plug it in. You'll find out that it is 120. All right. So 120 in this case, and I take the most that either has to offer in its variables, which would be a cubed and b. b is more than no b's. That's my LCM. Take a look at this one here. All right. What about our GCF between 10 and 14? Well, the greatest factor that goes into both of those is 2. All right, and then pulling my a's. A squared is the lowest a's and no b's. So that's my GCF there. All right, and then my least common multiple for 10 and 14. If we plug it in, we get 70. And the most that either has to offer is a squared, b squared. All right, try this next one here. Actually, I'm going to add into one here. I'm going to make this a little bit more complicated. All right, in this case here, greatest common factor, greatest number that goes into 27, 18, and 36 is 9. Fewest of our variables that any has to offer, a's. There's no a's here, so no a's is our fewest for a's. B's, there's no b's there, so b is our fewest there. And c's, just one c is our fewest. 9c would be my GCF. Let's look at our least common multiple. Now, least common multiple, in order to do 3, if you plug that into your calculator with the LCM and you try to plug in 3, it won't work. You'll get an error. You can only do 2. So what I want you to do is plug in 27 and 18. Go ahead and do that now. If you do that, you'll get 54. Now, to find the least common multiple of all 3, I need to do it again. Do the LCM and take your result of 54 and do that with the third number. It really doesn't matter what order you do this in. Just take 2 of them, find their least common multiple, and then take that result and use it with the third number. And if you do that, we find that our least common multiple here is 108. Now we take the most that either has to offer. Most of our a's is right here. A cubed. Most of our b's is b squared. And most of our c's is c squared. And that would be our least common multiple there.